this video, we're going to be taking a look at what it's like to build a computer with Logisim, some of the tips, tricks, and pitfalls that I've discovered along the way. This is definitely not a comprehensive tutorial about how to use Logisim. This is really just my experiences building a computer with Logisim, which predominantly have been really positive. So let's go ahead and kick things off. We're still going to be running at 8 Hertz today. We're going to hit Control K and start our simulation, and it'll load in our infinite add program today. We're counting in threes. Very exciting. We've loaded our program, and here we go. Hey, seems to be working just fine. So Logisim is a really great program simply because it lets you move really fast. If you want to start designing components and following along with Ben, it's so easy to do. You just drag and drop. You go from one place where you can have an input or an output and drag wires really simply and easily. I mean, just while this is running, I can drag out a wire here, for no real purpose, but you can see that it's very easy to go ahead and start experimenting around and doing things. The wires all have color indications, and the documentation is more than sufficient to explain all of that. The real issues start to come in when we talk about things like clock speed. Performance is not, it doesn't scale the way that you would expect it to. We can go to our tick frequency and increase it to 16 Hertz. And we can see it definitely moves faster. It definitely starts going faster. I really look at the output display for this sense because that's really the best way that I have to time all of this. So let's go ahead and pop it up to 32 Hertz. And it does definitely seem to move about twice as fast, but that definitely at some point breaks down. And if we go all the way up to the maximum 4.1 kilohertz, it's definitely not moving hundreds of times faster than 32 Hertz. I think that that's due to a variety of things. We have our bus monitor and our HDD over here, which is tied into the memory address register, which is why it's continuing to point around at things as the memory address register points at things, even though it's not being accessed anymore after it's loaded. We have this step counter over here. We have the clock and all of the lines associated with the clock. All these things have to be animated, and all the control lines have to be animated. The program counter has to be animated and updated. These things down here. But yeah, there's a lot of things going on here that that could be impacted by that fidelity problem. Really, at the end of the day, I like BB for its educational purposes, for me to be able to show people everything that's happening. And so I really don't want to sacrifice the visibility of each component simply for performance sake. It might be an interesting experiment to do sometime. I think we could definitely get the full performance out of it if we worked hard enough, but it's not worth it for the scope of my project here. So Logisim has a lot of pros and cons. It offers a lot of trade-offs. The conveniences definitely include easy wiring. We have the wire grouping. The component design is very simple. You can easily create chips. You can easily nest chips within one another, nest components together. You can edit things very easily across your entire, if you use a component 4 times, you can just edit the base component and all of the 4 copies update, which is very nice. There's a lot of out of the box components, and it's very easy to reset the circuitry. So there are really great things to be said for using Logisim. The click and drag thing is very, very great. It's very intuitive to just start building things, but there are some challenges, some difficulties. There are minor bugs which are sometimes really baffling. You can load a circuit and it's in an error state for some weird reason, and you just hit reset and it goes away, or sometimes you have to close and reopen the program, especially if it's been open a long time, or if you're running multiple instances of the program. Things like that can cause some strange bugs. There's deep nesting difficulties. We really struggle with circuits that are nested too deeply, so you kind of have to be careful about that. You have the only one universal clock speed to run off of. You only have the speeds that they offer, and you lose that simulation fidelity at some point. And it's definitely not the most friendly interface for large circuit design. So those are kind of the pros and cons that I've noticed, but it really is a great thing to look for and look for in terms of open source. Again, it was suggested on the flagship episode of Ben and Blue podcast that Ben Eater does with two other people that he worked with at Khan Academy, and they discuss education and a lot of great things. You get to know Ben Eater better, which is really cool. And they in the first episode, he suggests that people have used Logisim, and hey, it's open source. You get what you pay for, and in this case, you don't pay anything, and you get something that really does kind of let you hit the ground running with whatever experience or knowledge you have. I started with no experience or knowledge about computing. I had done basic circuits in physics class in high school, so I hadn't really explored computing in this in-depth way. And now I've been able to build an entire working computer. So Logisim has a lot going for it, and I highly suggest it. The link to Logisim is in the description below, as well as a link to the podcasts for Ben and Blue. There are other simulators that are out there, but kind of the last thing that really kicks Logisim into high gear for me is that I can use Python to generate the read-only chips and the RAM chips and load in pre-made images. In the future, we'll look at the compiler for BB, and in BB 0.3, the compiler is really actually a compiler, and we'll start looking at how we can use this feature of Logisim, the ability to load in RAM contents, to write very rich programming inside of a text editor, and have that be translated into our binary for us. So we derive a lot of convenience from using Logisim, and for those reasons, and for some of the interesting limitations that it imposes, which encourages my creativity, I give Logisim a solid thumbs up. Definitely go at it, and feel free to follow along with these videos as well, or download the circuit from the link in the description, and play around with a computer that's already built. So that's all I have for this video today. We've looked at some of the pros and cons of using Logisim to build a computer, and I hope that you've been able to take away something from it.